Today's lesson is scatter plots. Scatter plot is a graph that relates two groups of data. Most scatter plots are in the first quadrant of the coordinate plane because the data are usually positive numbers. This table shows data students collected on their test scores and the number of hours of TV they watched the previous day. We're asked to make a scatter plot of the data. Notice that there were two people that watched 0 hours of TV the night before. One got a 92, one got a 100. A couple people watched 2 hours. One got a 70, one got a 80. Down here there's one we can't see. One person watched 5 hours and got a 60. So we're just going to take and go to the first quadrant. We're going to label our graph, hours of TV watched and test scores. The horizontal axis is going to be hours of TV watched, and the vertical axis is going to be test score. So notice again, here's the point 0 and 92, and of course 0 and 100. And way at the end, we have 5 and 60, and then all the data points in between. This is a scatter plot. We don't try to connect these. We just draw the data points one at a time. In this you need to try to make a table, actually use the table to make a scatter plot of newspaper circulation and the number of households with televisions. Go ahead and pause the video now, try to make a sketch of this scatter plot, and then when you're ready to check your answer with mine, press play. Okay, let's see. I've minimized the data table so I have more room to show the scatter plot. It looks like, let's see, we've got newspaper circulation versus households with TV is the title. Newspaper circulation in millions is the horizontal axis label, and households with TV in millions is the vertical axis label. We probably could have picked a better scale for our axis. Instead of going from 0 to 55, maybe, or 65, maybe we want to go like 50 to 65 and just look at that piece. But this is what we have. We have these sets of data. So notice here when we have in 1950, 54 million newspapers were circulated. That's about this point right here. We only had 4 households with a TV. In 2000, we have 55 million households with circulation, and then we had 101 million households with TV. That was a peak for some reason. Try another one. The table shows the number of hours worked and the amount of money each person earned. Make a scatter plot of the data. So we've got hours worked and amount earned. Again, try this on your own. When you're ready to check your answer with mine, press play again. Go ahead and pause the video now. Okay, I've labeled this one student earnings. Horizontal axis is hours worked. Almost always, if time is a unit that we're comparing here, we're going to put that on the horizontal axis, and hours is definitely time. The amount earned is going to be my vertical axis. So Janelle worked 6 hours, made $25.50. That's represented by this point right here. Alex worked 9 hours, made $38.25. That's represented by this point right here, and so on. How'd you do? Now we're going to talk about correlation. You can use scatter plots to find trends in data. The scatter plots below show the 3 types of relationships that 2 sets of data may have. We have this first relationship. Notice how the data points are kind of clustered toward a line here, and they rise as we go from left to right. We call that a positive correlation, when they start to approach a line and they're rising as we go from left to right. And the second plot, notice how again we're approaching a line but we're falling as we're going from left to right. We call that a negative correlation. And in this third plot, the dots are just scattered all over the place, kind of like a shotgun shot hit it. And we just say that that has no correlation. It doesn't approach a linear type trend. A trend line, or a line of best fit, or just a best fit line on a scatter plot, shows the correlation more clearly. What we try to do with the trend line is draw a line that's as close as possible to every point in the data graph. So we've got this trend line and the other one. These trend lines are actually generated by Excel, and this is where Excel would have put those trend lines. The scatter plot shows the age and asking price of several used mid-sized cars. The question, what type of relationship does the scatter plot show? Well, is that a positive, a negative, or no correlation? We'd say that's a negative correlation. It's kind of approaching a line, even though it's spread out a little bit. It's not very strong. The closer these get to being on a line, the stronger the correlation. But we'd still see a negative correlation here. What does the point 14,900 mean? 14,900. I think that might be this one. What does that point represent? If you said it's a 4-year-old car with an asking price of $15,000 approximately, then you were right. Use the graph to predict the asking price of a 7-year-old car. So a 7-year-old car would be over in here somewhere. One way we can predict that is to try to find a trend line and then just see where that trend line hits 7 years. So here's a trend line. Trying to get a line as close to all the data points as possible, and that would hit at about $5,000 for a 7-year-old car. So we would use the graph and say that that would be about a $5,000 asking price. In this graph, is there a positive correlation, a negative correlation, or no correlation between the number of hours worked and the amount earned? Well, there better be a correlation, because if there's not, people aren't going to work. And you can see that these dots almost line up perfectly on the line. In fact, I believe they do line up perfectly on the line. So that's a very strong positive correlation. Another way to see that positive correlation is both sets of data increase. As the number of hours goes up, so does the amount of money that you earn. They both increase. That's a positive correlation. We're going to see a table that will show the number of missing assignments a student has in Algebra 1 and that student's current grade. This is actually real data from a few years ago in a class that I had. So the number of missing assignments that a student had in their current grade. Notice how everybody with no missing assignments has a C or better, and everybody with at least one missing assignment has a C minus or worse. So that seems to indicate that there's a correlation between the number of missing assignments and your grade in the class. Now we're going to make a scatter plot of the data. With this scatter plot, I've got it titled number of missing assignments in class grade. The horizontal axis is titled number of missing assignments, and the vertical axis class grade percent. This is kind of an interesting scatter plot. It doesn't look like any of the other ones we saw, because you can't have like a half a missing assignment or 3/4 of a missing assignment. So it really jumps from a bunch of 0 numbers to a bunch of 1 numbers to a bunch of 2 numbers and so on. So it looks kind of funny. But you can see a negative trend here. As the number of missing assignments goes up, the grade goes down. And again, we just answered that question. Is there a positive, negative, or no correlation? And there's definitely a negative correlation going on there. A trend line, I actually had Excel do this trend line. It comes right through here. If you let Excel go ahead and run the equation of that line, you get y equals negative 0.2307x plus 0.8694. That tells us basically that for every missing assignment, your grade is going to go down 0.25%, is the way this is working. Or no, that's not what that says. That's 23%. Your grade goes down 23% for every missing assignment, at least this early in that semester that we were looking at. That's our lesson. I'll see you in class.